What would I need to do to figure this out? Let's start with the easiest strategy. What would the easiest strategy be? Just keep adding 5 till we get to 71, right? That's just a lot of adding. What's another way we could look at it? Subtract 6. Because we know the first one is going to have 6 sides, right? We know that for sure. And so that would give us 65. And then if we divide 65 by 5, that'll tell me how many additional hexagons we can make. So what is 65 divided by 5? 13. So how many hexagons can you make? 14, because you have the 1 where we subtracted 6 plus the 13 you get with the 5 sides to get 14 hexagons. Another way you could have thought about it was you could have said, oh, well, to have 41, you have 8, right? And that's 30 more toothpicks to go from 41 to 30, or 71. 30 divided by 5 is 6. 8 plus 6 is 14. There's lots of different ways you could do it. Counting's a good option. Any of them work. Now, this is where it's a little weird. I want you to come up with a rule. So I want you to come up with an equation for how many toothpicks are needed to make n hexagons.
5n plus 6.
Okay, let's talk about that. 5n plus 6. Let's go up here and look and see if that works. So, or I'm even going to do this one. 6, 5, 5, 5. So obviously the 6 counts for this part, right? And then 5n. N is the number of hexagons, right? If I did for 2 hexagons, 2 times 5, what is 10 plus 6? Would that be the right answer?
No.
No. But we're not far off with that idea. What was that? It's not minus 6 either. Okay? So how many times is 5 there for 2 hexagons? Do you know? 1, yeah. Okay. For 3 hexagons, how many times is 5 there? Twice. For 4 hexagons, how many times is 5 there? So instead of n, it's actually, do you know? It's what?
Instead of 6, it's 1.
No, not instead of 6, it's 1. That's not quite right. Instead of n, what is it? If n is the number of hexagons, n minus 1. Because instead of 3 5s, there's only 2. So the equation is actually going to be 5 times n minus 1 plus 6. So if we look, each of these has, so like for 1 hexagon, how many hexagons is there with 5 sides? 0. N minus 1 is, or 1 minus 1 is 0, so that's that. Here there's 1, so 2 minus 1 gives us the 1, and so on. So that's the equation we use for that. We could also simplify that. If I wanted to simplify that, how would I simplify it?
5n minus 5. I mean, no, 5n plus 1.
Or, no, 5n minus 5 was right because you distribute. 5 times n is 5n. 5 times negative 1 is negative 5. Plus 6, what can I do from there? What is that? Yep, so that would be our equation in simplified form. So what we actually did just there is something called an arithmetic sequence, okay? So an arithmetic sequence, let me get the actual formal definition so that I don't mistell you the words again, is a sequence in which the difference between any 2 consecutive terms is constant. So if you look on the board over there, I have 2 examples of arithmetic sequences. So the first one, we have 4, 7, 10, 13, and 16. What is the constant difference between these two terms?
3.
What about from these two?
3.
3. These two? These two? So could I use that to find the next term? What would the next term be? Then the next term would be? 22. I can keep going, right? So now this is also an arithmetic sequence. Minus 4. Minus 4. And so the next term would be? So an arithmetic sequence is a sequence of numbers where the change in between the numbers is going to be either addition or subtraction. And it will be the constant the whole time. It will not change. And what is the difference between them is called the common difference. So it is the numerical distance D between any two consecutive terms. And when we're talking about terms, we are just talking about the list of numbers in the sequence, right? So in that example that's on the board, the first one, what's the first term in that top sequence? 4. What's the second term in that sequence? 7. What's the third term? Okay, and we can keep going for as many terms as is in the problem. So first things first is we're going to identify any of these arithmetic sequences. We're going to see which ones are and are not arithmetic sequences. So what we are looking for is a constant change with either addition or subtraction between the numbers, right? So for number 1, I'm going to go ahead and tell you this right here is supposed to be a comma. Yep. But now, what is the change from 1 to 5?
4.
Plus 4. What is from 5 to 9? 9 to 13? Is that an arithmetic sequence? Yes. What is the common difference in that problem? Plus 4. All right, for number 2, what's the difference between 1 and 3? 3 and 5? 5 and 8. Is that an arithmetic sequence? Why not? It's not a constant difference. It is different between 5 and 3. All right. For 3, what is the difference between 8 and 6? 6 and 4? 4 and 2? So is that an arithmetic sequence? Okay, for number 4, what's the difference between negative 5 and negative 8? Negative 8 and negative 11? Negative 11 and negative 14? Is that an arithmetic sequence? What's the difference? Minus 3. All right, for 5, what's the difference between 5 and 10? What's the difference between 10 and 20? What's the difference between 20 and 40? Is that an arithmetic sequence? Now, what do you notice about that one, though? They're all being multiplied by 2. That is a completely different type of sequence called the geometric sequence. And we're going to look at that a little bit later. But that is what there is a type of sequence with multiplication. And we'll talk about it a little bit later. It's called geometric. But we're not going to worry about that now. All we're worried about right now is it arithmetic or not? So for 6, what is our constant? So is that arithmetic? So now we are going to use the common difference in order to find the next terms. So what is the common difference for number 7? Plus 4. So what's the next term?
25.
Then?
29.
Then?
33.
Okay, what's the common difference for number 8?
Minus 3.
Okay, so what was going to come after negative 4?
Negative 7.
Then?
Negative 10.
Then?
Negative 13.
Okay, what's the common difference in number 9? So after 10 is going to be?
16.
After 16 is?
22.
After 22 is?
28.
28. Because 22 plus 6 is 28. All right, so now we're going to look at the formula we can use for any of these, okay? So we can set up an equation for the nth term of an arithmetic sequence, okay? That just means any term, okay? It can be the 93rd term. It can be the 5th term. It does not matter. We can use it to find any of them. And the formula is an, or that's a subscript, is equal to d times n minus 1 plus a1, where d is our common difference, and a1 is our first term. Then when we're talking about this, an is the number term we're looking for. So if it was a5, that means we're looking for the 5th term. If it was a19, we're looking for the 19th term. If it was a20, that means we're looking for the 20th term. So we will plug everything into this one formula. And if we look back at our toothpick problem, isn't that what we got right there? The common difference times n minus 1 plus the starting point. So in order to do number 10, we first need a1. What is our first term of that sequence?
7.
Okay, then what is our common difference? How much is it from 7 to 13? 6. From 13 to 9, or 19? From 19 to 25? So the common difference is 6. So we have to set up the formula first. We're going to do an is equal to our common difference times n minus 1 plus the first term. And in the directions, it tells us for all of these, we're going to find a19. We're going to find the 19th term, okay? I chose the 19th term specifically because I didn't want you to be able to easily add to get it, okay? I want you to actually have to plug it in. So when we go to do this, everything will stay the same except we're going to change n to whatever this number is. So in this case, we're going to change n to 19. And then we can take and input that directly into our calculator and get the answer. So as long as you put it in just like this, parentheses and all, it will immediately output the right answer. So why don't you go ahead and do that for me? Get your calculators out so you can do that. It is just this part. You're trying to tell me what A19 equals.
Ms. Williams, how do you put a subscript on?
You don't have to put the subscript in there. You do not put the A19 in there. All you do is put the number part. Because we are saying what that equals. So you should just do 6 parentheses 19 minus 1 parentheses plus 7. It's 115. So the 115th term, or the 19th term is 115. Then we're going to look at number 11. For number 11, what is the first term? What is the common difference? -4. So to set this up, we start with our equation. So AN is equal to -4 times Times n minus 1 plus 30. And then we still have to find A19. So I'm just going to take and plug that in. And I get negative 4 times 19 minus 1 plus 30. And what does that equal to? Negative 42. And that is the 19th term in that sequence. All right, for number 12. What is the first term in that sequence? What is A1? What is the common difference? Plus 3. Okay, so our AN is going to equal 3 times N. We could either do plus negative 11 or just minus 11. Either way works. And then we're going to calculate A of 19 by plugging in 19. So get 19 minus 1 minus 11. And use your calculator and tell me what that is. What was that? 43 is correct. I want y'all to do 13. What is the answer to 13?
34.
It's what?
34.
Oh, it is 34. My goodness gracious. I was looking at the wrong problem. I was like, what? All right. Now, we're going to go ahead and look at the application problems. So the word problems. So when we look at question 16, it says you visit the Grand Canyon and you drop a penny off the edge of the cliff. The distance the penny will fall is 16 feet for the first second, 48 feet for the next second, and 80 feet for the third second, and so on. So that is our sequence. Okay, it wants us to write the formula to represent that sequence. So what is our A1? What is our common difference? 32. So to do our formula, we do AN equals, which one needs to go in front? 32 times N minus 1 plus 16. And then it asks us, how far will it travel after 6 seconds? So what am I looking for there? A6. So we will do 32 times 6 minus 1 plus 16. And use our calculator for that. And we're a word problem, so we have to answer in context. So what's the context here? It's 176 feet. All right, now for 17. We have the total bank loan for Sarah's new car is $12,265. The bank withdraws $295.80 each month to pay for the car. So if I wanted to set this up as a sequence, okay, the first term would be what? What's the first total that we have? To get the next one, I would need to take that number and subtract. So if we do that, we get 11,000. What is it? point. And that would keep going. We just keep subtracting to get to the thing. So it wants us to write the formula for that. So what is our first term? What is A1? Now what is our common difference? Did I add or subtract that? Subtract it, so it's negative. So now we set up our formula. AN equals negative 295.8 times n minus 1 plus 12,265. And then it wants to know what the balance of the loan will be after 2 years. So what do I need to plug in to do that? 24. Why is it 24?
Because it's each month.
It's each month. 2 years is 24 months. All right, so when we plug that in, we get negative 295.8 times 24 minus 1 plus 1,000 or 12,265. What does that give us? 5,000 what? All right, and how am I answering that in context? It is dollars. And so what does that mean? I need to change 0.6 to it. It means to be 0.60. All right. I want y'all to finish 14 and 15 for me real quick. And those are you're still finding A19. Yes. What's the answer to number 14?
I got negative 106.
Negative 106. What about for 15?
I got negative 106.
So once you finish those two, we have 5 of these questions on Delta Math. 5.